Oh, I was telling he probably.
Okay, Pradeep is here.
Yeah.
And Deepak. They both already joined. Wow, we're late to the party.
Okay, I see.
Yes, it is.
So yeah, you should set the test and you should give the review. Oh, the review. You'd be here for a while, I think.
All right, can y'all hear us? No?
Yeah, we can do.
Okay, cool. Is the board clear-ish?
Board is okay. If you write something, then I can say is it clear or not. But we can hear you. We can see.
I think you have to move so that it doesn't focus on
me. Can you read what I wrote?
It's a up dog or something.
Yeah, it's up dog.
What is
It's
that?
a little bit blur. It's not
Nothing much
clear. Let
dogs,
me.
you know.
Oh, it's
Someone asked what's up dog, you say nothing much, what's up with you?
yeah, it's like a word play kind
It's
of thing.
the joke.
Yeah.
And you'll be like, it smells like up doggy here.
They'll be like, oh, what's up dog?
Yeah, that's I know that. What's up, dog? Yeah. Okay.
Yeah, that's
Oh yeah. Oh, so now you silent the word, shorten that also.
no, I just say up
Up
dog,
dog.
and you go, oh, what's up dog? And I go, nothing much dog.
Oh. So is this focused?
Oh, I erased it, so I don't know.
But if it is manually not focused, then it will keep changing.
It's a little bit blur.
It's a little
It's
blurry.
focused, I guess.
I also used a pretty bad marker, so half of it didn't write anything.
Okay.
Yeah, I'll
Like small.
can you read that?
Yeah, I can
Yeah.
read this. It's a little bit blur, but I can read this much.
I mean, does it change when he comes into the board and when he's or in the
Like, does the focus change?
No.
No, no, even
I don't
you
think-
see a little bit blur.
yeah, then maybe you can control it and see if it is in manual focus.
I think one thing is also that Zoom messes with the quality because when I look
Oh.
on my phone, it's perfect.
Yeah,
Okay,
then not
we can try through phone. Okay, then.
Is there autofocus?
Okay.
The
apparently.
autofocus automatically turns on.
Yeah, generally it is by default it is autofocus.
Usually it's autofocus is bad when you shoot video.
Can you?
When you shoot video, autofocus, like if you're moving, it'll change the focus like all the time.
Yeah. But that's what we try to remove it, but it's a pain. Or I guess you could permanently make it out of focus. But then if the board is farther.
The last time I used it, I turned off autofocus, but then the end of the like the recording, I don't know if you look back at it, was extremely blurry.
Yeah, you said that, but I didn't look into it. I haven't looked. Okay, we have two. So, so what are we doing?
I just try to check from phone if that work.
What? I'll turn. Computer?
Oh, yeah. I'll just turn it around regularly.
The photo is clear in phone.
It's not letting me join the camera for some reason. It keeps saying unable to join.
I think now it looks okay.
Okay,
Sorry,
so
Dr.
you're
Sajesh.
not
I
doing it.
thought from home is also okay. That's why I stopped.
Okay. Yeah, that lets me not to handle it. Okay.
Okay.
Okay, what do we do? We were
Yeah.
suggesting we can go to bar and.
Take the computer to
Yeah,
Take the
and
computer to
not
bar.
do anything.
I think that one is okay. We can see. Okay, Pooja and Roki, they are not here yet. For me, I'm thinking about question number 5 of the homework 8. 5 or 6, any of that.
Of homework 8. And when you say you're thinking, what does that mean? What's the expectation?
I did, but I'm not much clear about all of my work. That's why
So you want me to go over it? Is that the point?
something like that. No need to go everything. If you just give the hints, then I'm okay with that.
Homework 8, right?
Yeah, homework 8.
Okay, homework 8, which question?
Question number 8. Sorry, question number 5 or 6. Any of these. 5 and 6 are like almost same.
Okay. Isn't the homework already not due?
Homework
You have
8, yeah.
You have submitted it.
No, I already submit and then get the grade.
I see, I see. Okay.
Yeah.
So yeah, I can go over this if it will help. Is that something all of you want?
Yeah, I'm with that.
Right, number 5 or number 6, which one you pick one?
6 is okay, I guess.
6 is okay. Yeah. That's 2
Even
region.
5 and
I think both of them are similar to each other. 5 and 6.
You know. Okay, let's see. Again, tell me which one to pick. I think exactly both are almost very similar. So tell me which one you want to pick.
okay, let's go with 6.
Number 6, okay. So is that here? Can I begin?
Sanya is not here. Everyone is
2,
here.
3, 4, 5, 6, 7. Sanya, right? Yeah. Last time also she did not join, right? So that's okay. Yeah.
Yeah, she didn't join last time also.
And she got full points. So if she comes, she will spoil that. So I think it's better. She's better off without my instruction. Okay. So the equations remind me of problem 6, right? And this is homework
8.
8. Is this readable?
Not 100% clear, but when you speak and write, that should be okay.
Okay, now I should learn to write bigger. Better?
Yeah, this time.
This is
The
better?
problem is not writing. The problem is like that zooming quality. That's so the little bit blur, not like a small. If that one is like a distinct, then we can read easily. But video shows little bit blur.
So this is also blur, really? Okay, so
Yeah, we can read each word, but the problem is when we see the exact, your H is tilted little bit for us.
what is little bit for us?
Your H, yes, W,
Uh-huh.
H is a little bit tilted right side.
Yes. Repeat that.
So that one is tilted in the right side.
What is tilted? I don't get it.
Okay, H, we expect that H is straight H, yeah?
Oh, here, this one. Oh, yeah. Oh, you mean this edge? Yeah, yeah.
Yeah, H should be straight, but in our video that comes like something.
Which one is straight in this?
The center one is straight than other two.
Yeah, that's what it is for us also.
Okay.
Yeah. I guess gravity is the same on Zoom. I guess. Yeah. Yeah. Okay. I don't know.
You guys are in fourth floor, that's why maybe.
Ah. Okay. Okay. So tell me the problem. So this is what? What's the differential equation? Minus, right?
Yeah,
Minus d by dz square
plus k square.
plus k square.
Uh, inside the bracket.
Tail is logged in from here. Plus k square and
Bracket close.
okay.
Epsilon naught g dash.
Epsilon naught z.
G dash. G.
Oh, g. Yeah.
Yeah. G dash. Yeah.
Okay.
Which is equal to delta z minus z dash.
That's prime. Yeah. Good. That's it.
Yeah.
Okay. And z primes have limitations. Correct. Z
Yes.
is less than a and greater than 0.
Yeah.
0. And the same thing for z prime. Agree?
Yeah.
So the conditions, correct? Whenever we have this equation set equal to 0, first of all, right? So minus k square of, let's say, this could be anything, f, let's say, f of z is equal to 0. If that was the case, then what is our equation? Or let me write it the following way. G1, okay, yeah, so G1 z comma z prime is equal to 0 if z is less than z prime. Correct?
Yeah.
Because this is 0 then. So we have a line here that's 0, that's a, and somewhere here is z prime. So I could have z somewhere here or there. So there are two possibilities. So I call this 1, I call this 2, region 1, region 2, let's say. And same thing here, same equation. I would say is G2 is equal to 0 if in here that means z I can also say this is 0. So z prime is less than z less than a. Is that clear?
Yeah.
Okay. This is an easily solvable equation, correct? That just says that second derivative of G1 is equal to K squared G1. What is the solution to this?
Sine cosine.
Yeah, sine cosine.
No,
Oh, just e to the ik.
e to the, without I, without I.
E to the kz.
Easier to K and plus, or you can say sine hyperbolic and cosine hyperbolic. Either one, instead you say sine and cosine or exponential ik, x and exponential minus ik, it's sine hyperbolic or cosine hyperbolic. I think in this problem, the answers are given in terms of sine and cosine hyperbolic and cosine hyperbolic.
So yeah.
So the solution here is G1 of z min comma z prime is equal to A times sine hyperbolic kx
Or kz.
kz, yes, thank you. Kz plus B cosine hyperbolic kz. And G2 z comma z prime, they'll have the same, these are identical equations, except the coefficients could be different. So you say C sine hyperbolic kz plus D cosine hyperbolic kz. Okay, with me?
Yeah.
Okay. In general, there are 4 unknowns here, so we should have 4 conditions to begin with. But we already, I think there is some conditions given at 0 and A. Correct? So there are conditions given at 0 and A, and help me there. Does anyone have a printed homework? Printed homework aid? You
Not
guys
printed,
don't,
but I have it.
you don't use prints, right?
Yeah, I don't have it printed. I just
Yeah,
have it on
yeah.
my phone.
Yeah, I don't. I'm not
I
used
think
to.
I can come within 5 minutes.
Are you in the department?
No, I'm in home. Then I feel like I have to come there within 5 minutes because I didn't feel this much clear for me. I'm about to move from home.
Okay, you're this close, okay? See you soon.
Okay. After completing this question, I'll move.
Okay. Okay, guys, we. You don't need it? Sure?
Yeah.
Okay, thank you. Okay. Okay, now I have visible. Okay. First condition we put is that whatever is the solution must be 0 at on the left boundary. Right, so the function itself is 0, so that means G1. And there is an epsilon naught here, so we put that in here, but not. That's just a unit thing from the force function. Okay, so that's equal to 0, comma, whatever is the other quantity, irrespective of that, that's equal to 0. That means this Green's function evaluates to 0 on the left coordinate whenever that's set to 0. When z is equal to 0, that means z has to be z has to approach 0, so that means it must be on the 1 side, right? On 2, it can never approach 0 because z prime will stop you from doing that. So it must be G1 here. That's what I said in here. So you say that A times sine hyperbolic 0, right? A is 0, 0, right? B is 0. Right? Sorry. So that's 0 plus B. Cosine hyperbolic of 0 comes out to be 1. That's equal to 0. So immediately you get B is equal to 0. So we already did one part. Is same thing you use for A, so it has to be 0 at A also. And there the condition is that Z set Z equal to A. The second condition given is G1 A comma Z prime is equal to 0. Remember that these are physical requirements from the problem itself. The second two relations that is given is continuity conditions. But these are physical requirements from the system, that is from the problem itself that is going.
Why would that be G1 and not G2?
This one,
Yeah,
because Z has to be A, so it is G2, I suppose, it does it. Oh, I haven't even given you this. So at this point, I'm just saying Z is equal to A, but then A, if Z is equal to A, it must be in this region, so you would say that, so this implies, maybe G is equal to, this implies that epsilon 2 G2 A comma Z prime is equal to 0. Good point. Is that clear? There was a small confusion in what I said.
Yeah.
Let me. So here I see myself a lot. Give me a second. Thank you.
Can you please repeat one more time, please?
Yeah.
Sorry.
So what is given in the problem is this G,
Yeah.
and G is built out of two regions, G1 and G2, and that is defined as Z being 0 to Z prime. Maybe this diagram helps. Is this clear? So that's your 0. That's your A, and somewhere here is Z prime. That's the three variables. Z can be either in here or in here. If it is in the first part of the, if it is between 0 and Z, you call it as G1. So this is G1 and that's G2. Is that clear what I mean by that?
Yeah.
Okay. So when I say that G0 Z prime has to be 0, that means it is this point, which is on the left side. So G1, it must be G1. So this implies that G1 0 comma Z prime is equal to 0. Okay. Same thing in here, if I were to set Z equal to A, I'm on the right side. So it must be G2, so I say G2 must be equal to 0. Oops. Okay.
Yeah.
And this equal to 0 immediately means that C is 0, so this implies that D is equal to, so that is 0 plus D is equal to 0, that implies D is equal to 0.
wait, how did you get that?
Because G2 is C and D, so sine hyperbolic of, oh no, my mistake.
Yeah, it's still.
No, I'm glad that someone's correcting me. Thank you, thank you. So this is, so this time it's not 0, right? So this is C times sine hyperbolic of Ka plus D times cosine hyperbolic of Ka has to be equal to 0. Right? So the best I can learn is I can solve for one of them. Let's solve for D. So D then is equal to minus C times sine hyperbolic of K times A over the sine hyperbolic of K times A. Good. Okay. So I can replace D with C. So together what I can learn from all this is G1 Z comma Z prime with an epsilon naught is equal to B is 0, so it is A sine hyperbolic of KZ, where 0 is less than z is less than z prime. And the second one, G2 is equal to C, I'll keep the C probably, right? So C times, C is there in both. So C times sine hyperbolic of kz. And D is this, it is minus of sine hyperbolic of Ka over cosine hyperbolic of Ka times cosine hyperbolic of Kz. Is that clear?
Yeah.
So this is z greater than z prime and less than n. That's second part. Okay. We still have two more to go. A and C has to be solved for, but now we have two more conditions also for that. So now we go to the third equation and say that epsilon so this equation is called the continuity conditions. So G of z comma z prime, and z is equal to z prime plus delta, z is equal to z prime minus delta. What? No, top is plus and minus, that's equal to the condition is it is 0, so it's continuous. So it means that the value of the function on the right side is exactly the same as the value of the function on the left side. Is that clear? So I'll write that more explicitly here. So this means epsilon of g, when I'm coming from the positive side, that's this, right? So G2 of z prime comma z prime is equal to epsilon naught G1 z prime comma z prime. Is that clear what I wrote?
Yes, yes.
Yes.
Okay. Questions? Okay. And okay. G2 is on the right side, on the left side, I just have to substitute z prime so that it is right at that point. So substitute it there. We know G2 and G1 now. So G2 is C times sine hyperbolic Kz prime minus sine hyperbolic Ka. This is tangent hyperbolic, right? So why not write it as tangent hyperbolic? Let's save some ink. And cosine hyperbolic K z prime. So I've set z equal to z prime everywhere. And so that's G2, then I have to set it to G1. That's equal to A times sine hyperbolic K z prime. With me? Divide out by cosine hyperbolic maybe, so that makes it all tangent. So this is the same as C times tangent hyperbolic Kz prime minus tangent hyperbolic Ka is equal to A. Or A over C is this. That's what we can say. Right, so there's a connection between A and C you have found. With me? Yeah, okay. I divided out by cosine hyperbolic Kz prime everywhere. Oh, so then this will be tangent, so maybe that's right.
Oh, okay, yeah, that's what I was.
Yeah, okay. Yeah, scream at me. Yeah. Okay. Good.
Yeah.
So that's one equation, but I cannot do much. There are two unknowns, one equation, so I need to process more, right? So there's one more condition that I have to take the derivative of these quantities and at the boundary, at this boundary z prime, it is equal to -1. So let's take the derivatives. So epsilon, not much space, huh? At the
It's
okay, we'll erase this part. Okay. So derivatives, epsilon naught dy dg1 over dz is equal to sine hyperbolic is cosine hyperbolic. So it is k times a cosine hyperbolic kz. And epsilon naught times dg2 over dz is equal to k comes on both sides, so it is k times c. And this is cosine hyperbolic kz minus tangent hyperbolic ka times sine hyperbolic kz. Good thing. But I have set this, so there is a condition that. So I think we have used this part, so I'm going to erase this. And this diagram can stay, and I've used this also, so this I can remove.
Shouldn't it be plus 10 HK because cos hyperbolic?
No, sine and cosine, both derivatives or hyperbolics doesn't have a sign conversion.
Okay.
Sometimes, so there is no negative there. Trigonometric functions have that, but hyperbolic doesn't have the switch of sign. Right, so let me move this diagram to here. 0, A, V prime, and that's G1, and that's G2. So more space. And the condition we have is that epsilon derivative of G with respect to Z evaluated at Z equal to Z prime plus delta, and Z evaluated at Z prime minus delta is equal to -1. It's equal to -1. And that basically tells me that when this plus, that is G2, right? So that's this, right? So I have to evaluate it at Z prime. So it is K times C cosine hyperbolic of K C prime minus tangent hyperbolic Ka and sine hyperbolic Kc prime. So that's an above one, right? And minus of this, so this is minus of the one evaluated on the left side, that's Ka cosine hyperbolic of Kz prime. And this has to equal to -1. Notice a -1 there. Most of them are zeros, but now we have a -1 there. All the three conditions we had was zeros, but now we have a -1 there. So, and that is being squeezed into. Maybe I can erase that. The highlighted. Okay, so this equation stays right. Okay. Good. And that's it. So now we have two equations and two unknowns. I'm going to maybe process this a little bit. So I write this as C and K, right? So let me write this as divide again by any solutions, maybe cotangent. sine itself, right? Or what are we solving for? We are solving for c and a. Yeah, so divide out by k and write it as c and a. So I'll say c times. Yeah, let me write this as c times cosine hyperbolic kz prime. That's this term. And the second term is here minus a times. Did I do this correctly? Yeah. Cosine and sine. Cosine, sine. Yeah, seems all fine. Oh, but c has this coefficient in front. Yeah, I was missing. So, okay. So it's pretty much the same. It's yeah. So c times cosine hyperbolic of kz prime minus tangent hyperbolic of ka sine hyperbolic of kz prime. So that whole thing is a coefficient minus of a times cosine hyperbolic of kz prime is equal to minus 1 over k. I just took out the a on the right hand side. Nothing important there. I could have kept the k here, but for no reason, or maybe I like it that way. And the second equation is this one. And again, let me write that as we converted that into tangent, put it back into sine and cosine. Maybe that's probably better. So this was sine hyperbolic of kz prime minus tangent hyperbolic of ka times cosine hyperbolic of kz prime minus a times sine hyperbolic of kz prime is equal to 0. Good thing. Any questions until now?
Okay.
Okay. Deepak, Roki?
We are good till now. Yeah.
Okay.
Yeah, we're good.
That's a linear set of equations in two variables. We know how to solve this. Use your favorite method to do it. And what I do is I multiply these two and divide it out. So is there any favorite methods you have? How do you proceed?
What you were gonna do.
Huh?
What you were gonna do.
Okay.
Multiply.
Right. Okay. So I'll do, so you find C. What I will do is I will multiply the coefficient of this, multiply by this. Subtract that out, that's in the denominator. So cosine hyperbolic of kz prime minus tangent hyperbolic of ka sine hyperbolic of kz prime. Multiply this whole thing by, there's a minus sign also, so keep that. Sine hyperbolic of kz prime, and the negative sign I put it in the front. This multiplied by this, and there is a plus. That's more. Really not easy to work this on the board, but this minus means plus, right? Plus sine hyperbolic of kz prime minus tangent hyperbolic of ka cosine hyperbolic of kz prime, and multiply this whole thing by cosine hyperbolic of kz prime. All this is going to collapse in a sense. Okay. And the numerator is, replace this with minus 1 over k and 0. So that's minus 1 over k times minus, so that's 1 over k times sine hyperbolic of kz prime. That's it. Is that how you also do, or do you want me to tell how that is done?
You could explain that a little.
Yeah, yeah, so if you have two equations, ax plus by is equal to alpha. And cx plus by is equal to beta. Often what you do is you multiply this by c, multiply this by a, and then subtract or do, right?
Something like that, yeah.
Yeah,
This one.
anything is fine, but there is this nice relation that if you want to solve for x, right? By the coefficients alone, notice what I'm doing, a and c, whatever is on the left, I'm writing it as b and b. Is that clear? And I take the determinant of this,
Oh, okay,
right?
That's it.
So that's a times d minus b times c. That's this times this. Times that, that's what I wrote that down. And the numerator is, replace the first column with alpha and beta.
Let me be, okay.
And y would be equal to the same thing, a, c, but now you replace the second column. The denominator stays the same. And we have to do this in a minute
Okay.
on that. Okay, we have to do the d also.
Thanks.
With me?
Yeah.
Okay. Let's process the denominator a bit. It should simplify, I guess. So denominator has cosine hyperbolic, sine hyperbolic, so this is denominator, denominator, right, denominator. So that's minus cosine hyperbolic kz prime, sine hyperbolic kz prime, that's the first term. Then there is plus tangent hyperbolic Ka times sine hyperbolic square Kz prime. And next is plus sine hyperbolic Kz prime and cosine hyperbolic Kz prime. And we have minus of tangent hyperbolic Ka times cosine hyperbolic square Kz prime. I mean, these two cancel out. So that's equal to minus tangent hyperbolic Ka times cosine hyperbolic square Kz prime minus sine hyperbolic square Kz prime. What is cosine hyperbolic square minus sine hyperbolic square?
I see one.
One. Right, very good. So this is equal to minus tangent hyperbolic or tangent hyperbolic K. Finally, there is a simplification. Am I right? Nothing. Question?
I assume know the den then. I didn't know you meant.
Oh, denominator, sorry, yeah. I didn't want to, yeah, somehow. Yeah. Is that?
Yes.
So this whole thing is equal to minus 1 over k times sine hyperbolic kz prime over tangent hyperbolic ka. Right, so now we have c. Do the same thing for a. So the only thing that changes is denominator stays the same. That was the whole idea of doing the denominator. And instead I have to so numerator is, so this is the denominator. So let's do a level. So a would be equal be equal to denominator stay the same, and now I have to replace this with minus 1 over k and here. So this times 0 and this times minus 1 over k, so it is minus 1 over k times this quantity, so that's sine hyperbolic kz prime minus tangent hyperbolic ka cosine hyperbolic kz prime, and the denominator is simply tangent. No, minus tangent hyperbolic. A. Right. So A is equal to, maybe, I think I don't know to write this. Minus minus goes away. And is there any simplification? So maybe just leave it as it is. We will see how it goes. One can see that there is a Ka minus Kz actually. Yeah, we'll come to that. Yeah, that's a simplification here. I'm going to delay that simplification. Good. So we have two unknowns. Also, the unknowns are already found now. We can substitute it in the solutions, and then we are good.
Yeah,
So
we
let's
can
start.
find out.
Tell that again.
I think we can find out after substituting the A.
Oh, so from here you want to proceed? Is that what all of you want, or I can finish it?
Might as well go ahead.
Yeah, let's finish it so that it's complete. Okay, so I think that
Okay.
will help. Yeah, we are almost there, but let's not skip. I would prefer finishing it. Okay. So this is my D, right? No, this is my C. So then I erase this. So epsilon to 1 is equal to A times sine hyperbolic. So it is A is that. So we have 1 over K. And then there is tangent hyperbolic of Ka. And sine hyperbolic Kz, sine hyperbolic Kz prime. And a minus of tangent hyperbolic Ka times sine hyperbolic Kz, sine hyperbolic Kz prime. Sorry, I should have kept this outside itself. Apologies. Okay. So let's process this in a different way. Sine hyperbolic of Kz times whatever is there. So this is the same as sine hyperbolic Kz prime, sine hyperbolic Ka minus sine hyperbolic Ka and cosine hyperbolic Kz prime. And the denominator, you have cosine hyperbolic of Ka. And that has this is an identity for sine and cosine. This is a double angle formula. So this is the same as sine hyperbolic Kc stays the same. And here it is sine hyperbolic of K times Z prime, which is bigger. I think it's Z prime minus A, which means I have to bring in a minus sign on. No, that's side of these, right? Sorry, yeah. And cosine hyperbolic cancels out. I have sine hyperbolic Ka. Better? Is that the solution? Do you guys have the solution with you? There's a question. Oh, here. Then give me the computer if it is not locked.
What? I didn't already get it.
Yeah, that's exactly the solution for G1, right? That matches. Oh, except for A minus Z prime. Why did that mess? Why did I mess up a sign? Why did I lose a sign? Help.
So what's the solution?
So this is A minus Z prime.
Oh, not Z.
A minus Z prime. So what's the identity? Sine, cosine, sine is sine of. What is it? E raised to. Yeah, e raised to x minus e raised to minus x times e raised to x plus e raised to minus x minus of e raised to x minus of e raised to y, right? Y. And e raised to x plus e raised to minus x. So this is the same as e raised to x plus y. This is minus y. This cancels that. So the cross terms cancel out and we have e raised to minus x plus y. Those terms cancel out, sorry. So this is canceling that. So this is e raised to x minus y minus of e raised to minus of x minus y, which is sine hyperbolic here. So where did I lose the sign? Help me. There was a minus sign here.
Just gotta take care of it there, but okay.
I erased most of it. So So this identity is correct. So this is the fine.
Maybe the homework is wrong.
Now,
So
that because I took a limit, right? In part C, I took a limit and verified it with another answer. So I suspect that this is, and it also makes sense because almost when I was writing it, it was always the larger minus lower that you will write A minus Z prime. So it's sort of a physical need. This is a field between a conductor, two conductors that shows up. So this is a physical problem. So sine hyperbolic, let's see. Can we match this? This is a z minus a. Okay, here itself it doesn't. Okay, I want the identity clear. Maybe this is correct. Okay, x minus no x. This cancels that. E raised to x minus y minus of e raised to x minus y. This cancels out. E raised to what is e raised to minus x minus 2 times that plus e raised to x minus y. You of that. It is equal to sine hyperbolic of x minus y. So the first one, the sine comes with the first one, that is right. But why do I write? I write this as a minus z. So here itself, it doesn't match. Can we check this? When I did the z. And that was coming from. Yeah, let me check this one. So epsilon times G2 acting on A comma Z prime was equal to 0. And that is C times sine hyperbolic G2, right? G2. Sine hyperbolic of KA plus D times cosine hyperbolic of KA is equal to 0. So that means D gave me. So that D is equal to minus C. Equal to minus C sine hyperbolic KA over the sine hyperbolic KA. So that will make this Z minus A, isn't it? Oh, and then I say that C prime is equal to minus C. Yeah, this is correct. Okay, so this is fine. Because I say right after equation 24 that C prime is equal to C over minus C over cosine hyperbolic K. Okay, so 24 matches, and then there are no steps in between. Oh. We erased everything. So this is all correct. I think it is fine. Yeah, I'm going to redo this. Okay, that's the only way.
Yeah, if I see it, because I wrote it down.
But this time I will be slightly smarter as I was in the homework. I will try to write this as process this here itself, cosine times this. So this is C times sine hyperbolic KZ minus A over cosine hyperbolic of KA. Is that clear?
What did you do?
Okay, so let's start from here. Let's start over from here. Okay. This is two solutions. We agreed on that. Like I think this is fine. So I start over from there. I'm going to erase everything. I think there is some. If we do the simplification right away. So epsilon G1 is equal to A times sine hyperbolic AZ. And epsilon G2 is equal to C. Take the denominator out, take cosine hyperbolic Ka out. And make this common. This is sine hyperbolic Kz cosine hyperbolic Ka minus sine hyperbolic Ka cosine hyperbolic Kz. That's okay. This is equal to C times cosine hyperbolic Ka. You combine this together. So it is K of Z minus A. But I want to rewrite this as a minus z because usually a is greater, so this is not necessary to do. But I would like it like that. That's just a style. Here, a minus z. So I pulled out a minus sign. Okay. And now we have to find the continuity condition and the derivative condition. Continuity condition is that this is equal to this at z prime. So a times sine hyperbolic az is equal to evaluated at z prime, right? Evaluated at z prime minus c times cosine hyperbolic ka times sine hyperbolic k of a minus z prime. Are you following with me? Stop me if I'm. Oh, what happened, Pradeep?
So do you say he's on his way?
Oh, is he on his
I think-
way?
Yeah, I think he's on his way.
Okay. So it's not clear on the other side?
Sorry,
No,
what?
it's clear. Like we can see.
Okay. Oh, so thank you, Puza. Yeah, you were quiet all this time.
No,
Okay.
I am like watching everything. I joined from the mobile phone, so that's why I turned off the video because the phone is on my hand. So
Okay, that's okay. Yeah. Okay, so this is clear? Any questions? Roki?
Yeah, clear.
Okay.
Okay.
Oh, here, Pradeep is here. That was quick. He's in the office, Sarah. Okay, so the derivative now, we have to take the derivative of this. Like first is G2, right? On the right side. So take the right side. This one, right? Take the derivative of this. That's minus c over cosine hyperbolic Ka. Derivative of this is cosine, right? Cosine hyperbolic of K, A minus Z, but then I have evaluated Z prime. There's a negative sign coming from here, make it plus, and then there is a K also coming in. That's a derivative of this quantity here. Should I do that slowly? I think it's better to just solve that stuff. So I think I can erase this more space. So this is the continuity condition. So now I'm doing dg2 over dz minus dg1 over dz. That's my right side, that's my left side, is equal to -1. Right? That's the condition. I evaluate this on at z prime, evaluate this on z prime, and that's set to 1, right? So this is z prime. This is evaluated with z prime. So that's the same as the derivative of this is minus c over cosine hyperbolic Ka, cosine hyperbolic of K, A minus z prime, and then there is a K, and it kills minus sign, right, when I take the derivative. Do the same thing for 1, with 1, that's here, so it's minus of K times A cosine hyperbolic of Kz prime, that's equal to -1. That slightly looks simpler. So let me write that down here, these two conditions. So the equation now. So A times A sine hyperbolic coming and going. Sine hyperbolic of K z prime minus, this minus becomes plus C over C times sine hyperbolic K of A minus Z prime divided by cosine hyperbolic of Ka is equal to 0, right? That's plus. And the other one is K, I can take it to the right, so it is. A times cosine hyperbolic of KZ, fine, that's this term. I'm putting a minus sign everywhere. So minus of C times cosine hyperbolic of K of A minus Z prime. That's a minus sign, and this is equal to 1 over K. Okay. Yeah. Right, so that's the two equations, solve for them. So A would be, so let's do the denominator first, right? So usually that's a simplification. The denominator is equal to coefficients, so this is sine hyperbolic KZ prime times cosine hyperbolic K of K A minus Z prime. Divided by cosine hyperbolic K, so that's this times this, and I need a minus sign too. And minus of cosine hyperbolic K Z prime and sine hyperbolic of K A minus Z prime divided by cosine hyperbolic K. This is minus and a minus, so it is sine hyper, so it is minus sine hyperbolic K of Z prime plus A minus Z prime. Right, the two arguments add up, so that's cosine hyperbolic Ka. So that's the same as minus tangent hyperbolic Ka. That's what we had earlier also. I think the denominator comes out to be the same. Okay, so eventually A now, A is equal to denominator, and then put this in here, right, 1 over K. So it is 1 over tangent hyperbolic Ka. And I'm solving for A, so that's here, 1 over K times this, the minus 1. And that is a 1 over K. Multiply that with sine hyperbolic K of A minus Z prime over cosine hyperbolic Ka. So that's the same as minus. Hopefully, this will give us the correct structure. K sine hyperbolic Ka. Is it any different from what we had earlier?
Yeah, the.
We're gonna K minus A.
Yeah, Z prime minus Z before,
Okay,
that's.
okay. Good. Okay, and C then is equal to 1 over tangent hyperbolic Ka. C is this multiplied by what C, right? So this multiplied by 1 over K. This. Okay, so my solutions were here, right? So I can write my solution as epsilon 1 U1 is equal to A times sine hyperbolic Kz. So I still have the minus sign. Up there. So sine hyperbolic Kz sine hyperbolic K times A minus Z prime divided by sine hyperbolic Kh. And 1 naught times V2 is equal to minus C times this. That is minus. Is there a negative sign here? Oh, okay, well, first I will finish this up. Maybe the equation itself, I don't.
Yeah, that is not good thing. If you need, you can.
Oh, yeah. Yeah, thoughts, fine, so, okay. Q is minus C. Times C is the minus, so the 1/k. Times sine hyperbolic of K of A minus Z. And sine hyperbolic KZ. So I'm off completely by a sign. Which is because. Yeah. I was here earlier, and I think you can do that.
It's. We're around the same part, Sam. Should we? Are you kidding me? Yeah, I was already.
Oh, really? So you guys say that the question is wrong? Okay, so let's check the limit then, right? So this is the answer we get apparently, which is off by both these negative signs. So overall sign is off from the solution. But let's check. Apparently, we had a previous problem. We should get the same answer. So we can take the limit, correct? In the limit Ka tends to infinity, a solution which corresponds to moving Z to A to obtain the Green's constant for a single perfectly conducting lap. So yeah, so the limit is sine hyperbolic Ka over K limit Ka tends to infinity. Is okay. So what is Ka, right? So the sine hyperbolic KA in the limit this is e raised to KA minus e raised to minus KA over 2, I suppose. So I have to do, I take a limit KA tends to infinity. This goes to 0 in that limit, but this explodes. So I have taken KA from here and there explodes. So let's do that. So sine hyperbolic KA minus Z is equal to 1/2 times exponential KA minus KZ. And here it is minus of exponential of minus KA plus KZ. So divide the two. So divide the two sine hyperbolic K times A minus Z or sine hyperbolic K8 in the limit K8 tends to infinity. This is exponential K the minus KZ. It's exponential of minus K1 plus KZ divided by exponential of K8 minus of exponential minus K8. In the limit, these tend to infinity, these to go to 0, right? This is exponential of a large number, 0, 0. And this is expected to blow, but both have the same number. So the extreme limit, this is divided by Ka. And this also cancels out, so simple exponential minus Kc. Right. So that gives you that piece here, so this limit. So this goes to, so this is Z prime. Yeah. So this is equal to minus 1 over K e raised to minus Kz minus e raised to minus Kz divided by 2, and these two give you exponential of minus Kz. Right. Does that match? Oh, there is a minus on there. This is 1 over the K. So this is here same as I'll write this term first. Minus Kz of C prime. That's be equal to Kz minus C prime.
Multiplying that e to the minus KZ prime in.
This one we got.
Okay. What are we waiting?
I just substituted this in here and expanded sine hyperbolic case.
See,
So this is this. And this whole thing is minus Kz prime.
yeah, then you get yeah, minus e to the minus k times z prime plus z.
Yes, so let me write this as minus 1 over 2K.
Yeah.
Exponential of minus Kz minus Kz prime. This is plus 1 over 2K. Exponential of minus Kz and exponential of minus.
So plus, one is plus, I guess.
Last one, right?
Mm-hmm.
First one is plus, second.
Oh, first one is plus this,
Yeah.
right? Plus Kz minus this. And this is minus Kz prime. But I like to write that as so because Z minus Z prime. Yeah, this doesn't match, right?
Well, that's only G1, you also have G2.
Yeah, but if z was greater than z prime. Greater than z prime. Which is G1. Here. Oh, G1 is z less than z prime, okay. Oh, yeah, then it is okay. So this is G1, right? This is QK. So exponential of k minus k z prime minus z, right? So that's a positive number. Yeah, this now matches with that, except for this overall minus sign. Plus 1 over qk times, this is the same. This is z minus. Okay, so this sign doesn't match. Like overall sign doesn't match. I don't know why. That will be the exam question. Oh, yeah. Oh, now you have to go.
Yeah,
Yeah, go.
are you gonna be available tomorrow? Or do you
teach? I teach a lot tomorrow. It's not teach that there's a pot for you. So 11 to 12:30 is the
It's on focus.
11.
That works. I have quantum in focus, so I'll, if I have questions, I'll stop by. But I'm gonna go help out my brother.
Okay. Work on it?
He's got a motorcycle. There's a baffle in the exhaust. There's a bolt baffle. So I just like to put it back in.
Okay, go.
Okay, alright, so thank you, sir.
Yeah. Okay.
I think we can do
Extra credit for finding the minus sign error in the.
okay
Before Friday. No, not before Friday, before Monday, let's say.
before Monday. Friday.
Yeah, don't spend this time. Yeah, I'm not able to find it here.
Okay.
And
Okay.
I cannot check it because I nicely erased everything. But my apologies, sorry. But that's not an excuse for this not being asked in the exam.
Right.
Like me not being able to do is. Oh, I'm plugging in my passwords. Okay, yeah. Does this help? Did it help?
Yes.
Rocky, Deepak, Pooja?
Yes, sir. Yeah.
Yes.
Yeah, except for that negative sign, that would have been good. I would have felt better.
Yeah.
Okay. That's all? No more questions? This is it?
That one is for me. Maybe other have a question.
Anyone else has questions?
Because I only asked one question in.
Yeah, look for simpler, smaller questions, but like for example, here I can ask. Yeah. If everything had gone smoothly, the classic would have been I'll give this and ask you to take the limit. Like that's a short enough question that it can be done. If you know it, it can be done in 5 minutes, but even if you struggle, it will be 15 minutes or 20 minutes, you struggle and you could okay. So that's the questions I try to ask, which you can analyze in the 15 minutes that you have. I think 15 minutes per question is probably what you can expect.
Yeah, 15 per 1 hour. Yeah. We have
75 minutes, so
Oh yes, 75.
you have 4 questions, so 15, more than 15 minutes.
More than 15, around 20, 17.
Oh, there's not about 6 to take on. That's okay. So the quantum mechanics, I think if you follow the lecture, it's kind of clear. It is good if you try to understand it because that's the key to quantum mechanics in general. So I like to ask that. But I won't change from whatever we did. Whatever the simple things I did is all I would ask. But surely there is a question. The second one is Fourier transform.
Yeah.
Homework 7. Yeah, homework 7. Mainly the idea is that a poor man's Fourier transform is replace all the derivatives with I times k. Is that familiar? What I said, is that familiar? Deepak, Rocky, Tuza?
Yes.
Right. A poor man's Fourier transform is derivative replaced with. If it is position derivative, it is I times k. If it is time derivative, it is minus I times omega. So that's a. And typically that's how most of the time you use Fourier transform at a advanced stage. So I'll do something with that. It's my intention. Green's function. I don't think I have a problem yet, but something I was thinking in the morning that this is a second order derivative, second order differential equation. First order differential equations are supposed to be much simpler. Think of the drag problem. Like that's the first differential equation you encounter. So maybe the Green's function formalism for a drag problem. Like think of a source on the right side and make the drag problem a Green's function problem. That's something I've been thinking, but I'm not sure to phrase it so that it can be solved easy. It's the first order, it should be easier, significantly easier. There's only one variable.
Will be lengthy.
Hmm?
Second will be lengthy.
This one is usually lengthy, yes. But then I can always ask a smaller piece out of it. I have asked it, the way I have asked is usually I give the solution and ask you to verify it. I think that was there in the homework also.
The other one is first, second, third problem. I guess.
Correct, yeah. So those are all questions that were asked the previous semesters. So that's a simple enough problem that I asked them.
Yeah, those questions they are a little pretty okay for us.
So that's surely I can ask immediately, but I might do something related to first order differential equation. So that's my hope I can. And the Legendre polynomials, I did think of the problem. Yeah, just the properties of Legendre polynomial. There are 4 of them, right? 4 or 5. One is recurrence relation. Second is Rodriguez formula. Third is orthogonality condition, and the 4th is differential equations. You don't have to derive any of this, but you should have a clear understanding of what this means. I will ask you to apply this. Okay. So I have thought about a problem. I will ask you to use one of these to do something else. Right. Which is there in your homework. So in some form you have used it in the homework, but I'll rephrase it and make it simple. Like if you know it, it is can be done in 3 lines, but otherwise it will take a long time.
With the homework problem.
Yeah. And I graded most of who submitted it. I think you seem to have got everything okay. Yeah. The Legendre
I didn't solve the homework question number 9, that's why I didn't submit yet.
Okay.
And that is very lengthy, and then I feel like okay, I can complete
Yeah.
first side.
No, take your time to submit and then. And the last problem is already online.
Yeah.
Professor, can
Yeah,
you
that's-
explain a little more about the Fourier transform? I mean, the poor man Fourier transform.
Oh, I can write it down. What I meant was
Yeah, that should be more.
so what I meant was the poor man's. So whenever you're Fourier transforming, so you have. So usually there is a derivative, right? D by dx. If you replace your d by dx by ik, right? It Fourier transforms the problem. Like if there is an equation that involves derivative, and if I can do this, then it immediately Fourier transforms. Okay. There is one homework problem where you use this. Okay.
Okay, got it.
Oh. Yeah. Okay, and if it is time derivative, then usually it is minus I omega. It doesn't matter. It is a convention, so even if you write plus I omega, it should not change anything. Because overall that will be, that sign will come in. So usually that trick can be used to solve equations of. Did that help, Deepak?
Yes, sir. Thank you.
What is this?
No,
So this is just, oh, okay,
That's the question.
I didn't know what that was.
Can you tell me the solution?
I didn't know what it was. Look at that.
Your homework of one.
Are we good? Rocky, Deepak, Pooja, are we good?
Yeah.
Yeah.
So when will you upload this video? Today or tomorrow?
Oh, good point. I have to upload, right? Very soon. I mean, once we finish this, it takes about 5 minutes for it to show up on my email. But by the time I'm not left, so I'll reach home. And once I reach home, then I will eat. I not eaten since morning. Oh no, I have eaten chocolates, April's chocolates. So I'll post it in an hour or so, Rocky.
Yeah, that will be good. Yeah, because I have some network issues, so I see maximum time blur. So I was hoping
Oh,
to. So, yeah.
Okay. Okay, so let's wind up then. Okay, thanks. I'm sorry about the sign error.
No, thank you.
Yeah.
Thank you.
Mhm.